After studying in detail about the series and parallel combination of resistances, now let's see some electrical circuit, and try to solve the resistances. The first electrical circuit is, we take three resistors and they are connected in parallel to each other. Join this circuit by means of a battery. Now what we will do, that assign the numerical value to it, like 12 volt, 20 ohm, 30 ohm and the 60 ohm. Now let's find out what we have to solve in this electric circuit. Okay. First, we need to find the total resistance in the electric circuit. Second, we need to find the total current which is flowing in the electric circuit, which is denoted by capital I. Third, we need to find the current flowing through 30 ohm resistor. And fourth, we need to find the current flowing through, let's say, 60 ohm resistor. Look at the combination here. The combination is parallel. These three resistors are connected in parallel. So use the formula in case of total resistance, that is in parallel. So what will be the formula? That 1 upon RT is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3, because there are three resistances. So what is R1? 1 upon 20 plus 1 upon 30 plus 1 upon 60. Okay, now solve this. Take the LCM. 60, 3 plus 2 plus 1, it will become 6 upon 60. That is 1 upon RT is equals to 6 upon 60. So what will be RT? RT would be 10. So this is the first part that we can solve. Now let's see the second part. Okay, you have to find the total current of the electric circuit. This is the battery. It is supplying the total current in the circuit, that is capital I. So capital I is equals to V upon R from Ohm's law. What is V? V is the supplied by the battery, that is 12. What is R? R should be the total resistance, because you are going to find the total current. So total resistance we have already calculated in the previous part, that is 10. So your answer would be 1.2 ampere. Okay, now let's see the third part. In the third part, you have to find the current flowing through 30 ohm. Now, I have already told you that when in parallel circuit, when the current flows, that is I, as soon as it reaches this point, then now it gets split into three directions. So it will get constituted into I1, I2 and I3, like river. So in the case of 30 ohm resistance, what is the current? Current is I2. So you have to find I2. So what is I2? I2 is equals to the same formula, V upon R. What is V in this case? We have already discussed that in the case of parallel resistance, the potential difference of all individual resistance is identical to the potential difference of the power supply. So here the power supply, that is battery, is providing a potential difference 12 volt. So this 12 volt is same for 60 ohms. It is same for 30 ohm. It is same for 20 ohm. Now when you are going to find the current through 30 ohm, so what will be the potential difference? 12 volt. Just write down the potential difference 12 volt, which will remain the same. What is R now? R is 30. Okay. I2 you have to find and the resistor is 30. So it would be 30. So now solve it. You will get 0.4 ampere. Fourth part is for your homework. You can solve it. I60, that is the current flowing through the 60 ohm. So it would be I3. You have to find I3. Same if in your exam the question comes that find I1. So you know it, that V upon R. V will be remain same, that is 12 volt, because it is a parallel circuit. And what is R? R would be then become 20 ohm. Next, come to the another circuit in which the series combination is given. The next question is, this is a series resistance, okay. We have connected it by means of a power supply. Now, the voltage is V, it is R and it is 5 ohm. Across it, the potential is 10 volt and across this, the potential is Okay, so what you have to find now? You have to find first the value of V and R. Second, you have to find out the total current which is flowing in the circuit. Third, you have to find out the current which is flowing in capital R. Let's see the solution of it. How you will find capital V here? See, in the series circuit, what is the potential? The potential is the summation of the individual potential difference. This is the total potential provided by the battery. This is V1, this is V2. Okay, so in series connection, V is equals to V1 plus V2. So what is the total potential? That is V1 plus V2, 10 plus 6, that is 16 volt. This is your first part. Before finding capital R, you have to find out first the current flowing through it, because you know V, and if you will know current, then you can easily find out R. So let's find the current flowing in this circuit. What happened? The current flowing in the 5 ohm resistor. What happened? V upon R. What is V? It is given to you, that is 10 volt. What is R? 5 ohms. So, the current would be 2 ampere. Okay, now in the series circuit, what is the property in the case of series circuit? The total potential will bifurcate according to the resistance supplied. That is, if there are 2 resistance, so the total potential gets split into V1 and V2. If there are 3 resistance, then the total resistance gets shared into V1, V2 and V3. But in the case of current, when the total current passes in the series circuit, then at every point it will remain the same. That is, the current passing through 5 ohm, it will remain the same for total current also. So that means that the current passing through capital R is also 2 ampere. Now, R is equals to V upon I from Ohm's law. Okay? Now we are solving this particular part. What is V? It is 6 volt. See, the 6 volt is given. Current, I have told you the current in series circuit remains same. That is, it will remain as 2 ampere. So this would be 2 ampere and the R would be 3 ohms. So we found out the R as 3 ohms. Now, how you will solve capital I, capital R? For capital I, that is the total current, it will remain same as 2 ampere. For I flowing in R resistance also remain the same, that is 2 ampere. That is, total current capital I is also 2 ampere. The current flowing through R or 3 ohm resistor is also 2 ampere because it is a series circuit. Now let's discuss this concept numerically. What happened that let me draw an electric circuit. This is a circuit. No electric circuit is complete without a battery. So first you have to supply a battery. Next, place appliances, that is resistors in this case. In one arm, one resistor is placed. In the second arm, 2 resistors in series are placed. In the third arm, the 2 resistors in parallel are placed. This is a circuit. Now, all the resistors are of same value. That is, we can assign as capital R, this also capital R and these also, because all have the same value. Now, this is the total potential supplied by the battery and it is the total current given by the battery. When this current passes through these branches, then what happens? The current gets split up into various branches. When it passes through this branch, it will become I1. When it passes through this branch, it will become I2. When it passes through this branch, it will become as I3. Now name these branches. This point or this branch is named as say A, this as B and this as C. This is your question. You have to find the first minimum current in branch, that is A, B or C. And next you have to find the maximum current in branch. These are the 2 questions. Okay. Now let's see. There are 3 branches A, B and C. You have to find the minimum current in branch A, B or C. And next you have to find the maximum current in branch A, B or C. How you will solve it? You know the Ohm's law. The Ohm's law is I is equals to V upon R. Just look this formula very carefully. In this formula, the current and resistance are inversely proportional to each other. That is, when resistance increases, the current decreases. So, now, see at point A. Let's talk about this branch. What happened? The current would be I1. The potential remains the same because these are the parallel circuit, V upon, and your resistance is R. Now, at point B. The current would become I2, the potential remains same, V upon, the resistance is R. So, what is the total resistance of this branch of B? R plus R. Because the total resistance is calculated in series by adding the resistances. So, it will become 2R. Okay. Next, in C. In C, what happened? You have to find I3, which becomes V upon the total resistance. What is the total resistance in this branch? 1 upon R plus 1 upon R. Okay, that is 1 upon R plus 1 upon R. So, solve for total resistance. Okay, now on solving, you will get RT is equals to R upon 2. So, that means the total resistance which you are going to write here is R upon 2. Now, we have calculated the current through each branch, that is A, B and C. At A, the current is V upon R, at B, the current is V upon 2R and at C, the current is V upon R by 2. Now, tell me at which branch the current is minimum. This is V upon 2R. If the denominator is large, so the numerator would be very small. So, in comparison to these three equations, the denominator is maximum in the case of I2. That means I2 should be minimum. So, what is the minimum current flowing in the circuit? It is I. Now, what is the maximum current flowing in the branch? See, again, I1 is equals to V upon R. This V upon R by 2. That is, the R reduces by 2. So, the denominator becomes minimum and the numerator becomes maximum. So, what is the maximum current? I. So, this is how the question is solved. At the place where resistance is increased, at that place the current is minimum. At the place where resistance is decreased, then the current would be maximum. So, what we have concluded through this particular explanation, that whenever there is a series circuit, then the current is minimum, and when there is a parallel circuit, the current is maximum. I have proved you by this particular numerical also. Okay, so keep this in mind that when the 2 resistor or the 3 or the 4 resistor are connected in series, then the total current which is coming is minimum. When any resistances are connected in parallel, then the total current which is coming maximum.